Every system contributes to homeostasis. Two regulatory systems that affect and regulate most systems are the neural system, which provides a fast response, and the endocrine system, which offers a slow response via hormones and can only affect target tissue that has receptors. A sensor senses the disturbance in the controlled variable and conveys the information to the controller, which compares the deviation with reference to a set point. Then, it sends correction initiatives via effector mechanisms to correct it. For example, a change in blood pressure is sensed by the vasomotor center in the medulla, which then sends efferent signals of the autonomic nervous system to the heart and blood vessels to correct the response. The feedback mechanism involves a disturbance happening, which is fed back to the controller, and then action is taken. In contrast, the feed-forward mechanism allows the controller to anticipate a change even before it has occurred, enabling it to take the desired action without lag time. An example of a positive feed-forward mechanism is the cephalic phase of gastric acid secretion, where only the smell, sight, or taste can lead to an increase in gastric acid secretion without food actually being in the stomach. Another example is the increase in ventilatory drive just before the beginning of exercise to meet the oxygen demands during exercise. Cerebellar learning occurs through a negative feed-forward mechanism, where granule cells can inhibit Purkinje cells through inhibitory interneurons even before stimulating them. Feedback can be negative, where the controller does the opposite to change, or positive, where the controller does the same as the change. Negative feedback minimizes or cancels the error by the controller's effect, and 99% of functions are based on negative feedback. The gain of a negative feedback system is indicative of its efficiency, calculated as correction applied divided by residual error. For example, if mean blood pressure rises from a resting value of 100 millimeters of mercury to 150 millimeters of mercury for any reason, and correction brings it back to 110 millimeters of mercury, there is still a residual error of 10 millimeters of mercury in the same direction as the change, resulting in a positive sign. The gain would be calculated as 40 divided by 10, which equals plus 4. The higher the gain, the more efficient the system. In terms of gain for various systems, the kidney's regulation of body fluids in blood pressure has an infinite gain, as full correction is always achieved with an error of 0. The temperature regulating system has a gain of plus 33, while the baroreceptor in blood pressure regulation has a gain of plus 2.